see by the dawn's early light what so proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we watched were so gallantly streaming, and the rocket's red glare, the bombs bursting in air, gave proof through the night that our flag was still there. Oh, say does that star-spangled banner yet wave o'er the land of the free and the home of the brave?
You know, our speaker today, I don't know how we could have timed this any better. With the devastation in Florida and what all the other areas suffered from severe hurricanes and did millions of dollars worth of damage. My only concern, you know, all you people know I worked for State Farm for 35 years. I hope the hell they don't go bankrupt. That might affect my pension check. But there is concern that the damage is so bad that there's concern that some of these insurance companies could bankrupt over this. And so our speaker today is from the the Weather Service, and I'm sure that he can answer most of your questions. And with that, please welcome Fred McMillan.
Okay, good morning, everybody. Great to be back here. I think I was here like 4 or 5 years ago, pre-COVID. So again, great group of people here, great contacts. Short presentation here today. The title slide you have in front of you, that's a picture of our office. We're located across the river in Moon Township, Pennsylvania. Again, it's October. Frost is possible this weekend, so I grabbed the fall photo from last year. It shows you our office. The big thing in the front, on the far right, is our radar. So when you see radar on television, on the apps on your phone, on the computer, it all originates from that device right there. That rotates 24/7, 365 unless it's broken. It's always running. And then we also launch weather balloons at the building behind it, the smaller building, and we launch those twice a day. In support of Ian, we launch weather balloons 4 times a day to help the Hurricane Center and help our weather models capture the potential track for Ian. It's interesting because Ian, from the initial forecast to where it made landfall, the National Hurricane Center, again, they're really good at what they do. They were only up by 25 miles out 5 days. So again, very precise forecast, with some error, but it was still really good. 25 miles within 5 days, that's really good. So anyways, this is our office in Moon Township, Pennsylvania. I just wanted to show a picture of that where we work. And so again, I'm going to talk about hurricanes, right? So Hurricane Ian came through here last Saturday, made for a soggy Saturday. Really didn't produce much in the way of any flooding, thank goodness. Rainfall amounts were like about an inch and a half in southwestern Pennsylvania and over in eastern Ohio. So you see hurricanes, we call them hurricanes, but that's not the name they're given across the world. And in the Atlantic, the Eastern Pacific, we mostly call them hurricanes. In the Indian Ocean, they're called cyclones. In the Western Pacific, they're called typhoons. And then the really cool name is down in Australia, the Willy Willy. So it's sort of like Dilly Dilly from Ben Roethlisberger, he had. So it's something similar to that. But again, depends where you are in the world, gives you the name what the storm's going to be. So hurricanes, how do they form? So hurricanes really, they need a couple of ingredients. They need warm ocean water. And keep in mind, hurricane season runs from June 1st until the end of October, November 1st. And the peak of hurricane season is September 10th. That's when we see the most activity. Of course, Ian came last weekend at the end of September. So really, we're still 3-4 weeks to go in terms of hurricane season. So they need a couple ingredients. They need warm ocean water first and foremost. They need weak winds aloft. When I say aloft, I mean winds of, 20, 30, 40,000 feet, way up in the sky. And they need like a thunderstorm complex that, near the surface that kind of gets things going, develops these cumulonimbus clouds, and they start forming, and they get thunderstorms. And then what happens is they tap into warm ocean water, and there's light winds aloft, and they slowly develop a rotation. Sometimes they don't develop a rotation, sometimes they do if those conditions are favorable. If the winds are too strong, they won't. And what happens is a low pressure forms, it gets assigned a tropical depression number, and then if it intensifies, tropical storm, potential hurricane. Sometimes they say it's tropical storm. Once it become a tropical storm, they get a name. And one of the questions, I just gave a talk yesterday to about 400 kids online about hurricanes. And one of the good questions they had was, how do you get the names? So the names are determined by the World Meteorological Organization. They determine those in the wintertime. They have a set list, and names are recycled every 7 years unless you get retired. So Ian will likely be retired based on the amount of impact and damage it has. And so again, they alternate boy and girl names. So one named boy, one named girl, and then go back and forth. Fred was a hurricane last year, but I wasn't retired. I was out in the Atlantic Ocean just harming fish. So you'll see me back in about 7 years, back on the hurricane list. And so if you look at inside of a hurricane, right, there's a lot of cool parts to it. The eye wall, that's where you see all that damage in Fort Myers Beach, Sanibel Island. That's what really hit them, 4 to 5 hours of 120 mile per hour winds. And, inside, along the inside, the eye, of course, it's clear, it's sunny. But right on the outside, again, that's where the most damage is. The spiral rain bands impacted us. Again, that's an inch and a half of rain. But then also in the spiral rain bands, you can see tornadoes. Now, tornadoes, when you see with hurricanes, are very hard because they don't cause significant damage. I mean, they cause down trees or whatever, but it's hard to distinguish, with these outer bands, that this was a tornado versus just wind from the hurricane. Those are very tough. We go on and do surveys, but it's a challenge for us because they're mostly EF0, EF1, winds 65 to 85 miles per hour. Generally speaking, mostly cause tree damage. But the spiral rain bands lead to the heavy rainfall. So again, 3 parts. The eye, again, light winds, mostly sunny. You're like, wow, I'm in the middle of a hurricane, and it only lasts for a short period of time. Then the eye wall comes back, and the worst part of the storm comes to get you. And then of course that's where the damage is. Most storm surge, again, that's the big thing. It brings all that water, blows all that water inland from the Gulf. So if you saw pictures from Southwest Florida, again, storm surge reached like 9 feet. So again, water, if you're 9 foot elevation or greater, you saw water. And when the winds on the backside, when the winds blow out, you see the ocean get pushed back, and you see it walk. Not that you would walk out to the beach during a hurricane, but if you were to walk out there or had a coastal property, you would see beaches that you probably wouldn't see before, even during low tide, because of the wind just is so strong that it just pushes all that water back. Very powerful pieces of weather. So this is a map of all the hurricanes to impact Pittsburgh within 60 miles from 1850. So you can see, we got different ones. We got Gordon, we got Ian, we got Francis, we got Ivan, we got Ida, we got Ike. So the I name really impacts us. So when Ian developed, we were like, oh boy. And it's right around that time, late September, early October. So it's interesting that you look, most of the hurricanes that come through this region come from the south, of course, mostly from this, just west of due south. And so if you look at it, right, so in 2004, we had Francis and Ivan, 7 days apart, brought a foot of rain, caused massive flooding issues across the region. My friend had a wedding downtown Pittsburgh. No one could get to it because all the roads were closed. And without Francis, you wouldn't have the impact with Ivan. But again, since they were so close together, again, that caused, that was a worst case scenario. Ike, 2008, came through here and didn't bring a lot of rain, but it brought a lot of wind. And so much so that the air traffic control towers across the 3C airports in Ohio, Cleveland, Columbus, Cincinnati, all had to be evacuated down because it was unsafe to be in the air traffic control tower. And the Steelers played the Jets that day. And if you remember, it was like sunny, the sun came out, and then like the wind just started like early afternoon. It was, it caused a lot of power outage issues across Ohio, northern West Virginia, and parts of southwestern Pennsylvania. Of course, talk about Ida last year, right? So Ida, brought 6.5 inches of rain to parts of Washington and Allegheny County. Buses are stuck, stranded. We had numerous homes that were flooded down in Washington County. Again, so these storms, they make landfall in Louisiana, but they have impacts here in Western PA. So that's why it's always an important thing to kind of keep in mind that doesn't matter where it strikes, it could always impact us here locally. So again, and then of course we have the 10-year anniversary of Sandy coming up. Sandy didn't impact us so much so here in Allegheny County, but if you drive 2 hours to your southeast in Garrett County, Maryland, or down towards Tucker County, West Virginia by Canaan Valley, if you've ever been down there for a ski, hike, whatever, getaway weekend, they had 48 inches of snow at the end of October from a hurricane. So again, we've had our fair share of wild weather here, and so much so during that hurricane that there was a lot of moisture content with the snow. And so we went down there, we did core samples to kind of see, hey, in this 4 feet of snow, if this melts, how much water equivalent is in that, so we can model that into our rivers. And the ratio was so low, something like 4 to 1. And when we did our core samples, when the light hit the snow, the light would scatter, as it always does, to a color, and it scattered to the color blue. So it looked like blue. Kept on getting those reports of blue snow going on down there. We're like, blue snow? What are you talking about? And then we got pictures, went down to some samples, and that's what we saw. Very wild. So here's a picture. Again, we celebrated this anniversary here. This is Agnes back in 1974. This is the Golden Triangle at the time. Again, set the flooding record for Wilkesboro, Harrisburg. That was a big impact across the eastern part of the state. Again, not so much here, although we have significant impacts here on the Allegheny and the Mon River, but it wasn't nearly as bad as you saw over in the eastern part of the state. Here's a picture during Ivan. Again, similar thing, 2004, Golden Triangle's underwater, areas, on both sides, Allegheny and the Mon. So again, navigation traffic stops. So again, these are some of the impacts that they produce here. Here is Ida in 2021. So you can see, people being rescued from the bus. That map shows you a color scheme. So if you kind of if you can't see in the back, it's about, the orange and red is like 4 to 5 inches of rain that fell across parts of Allegheny and Washington County. Again, so that was over about a 24 to 36 hour time window. Again, big issues. If you live up in Beaver County, you probably didn't see too much. Or even over here, it wasn't that bad. But if you go over towards the east side of the city and then south towards like Cannonsburg and down that way, Houston, big issues down that way. So here's the picture that you may have seen. This is Fort Myers Beach from Ian that impacted again last week. So one of the things we always sort of tell people, right, so there's before and after photos. And one of the things that we always get asked is, okay, well, in that bottom picture, why is that big building still really the only thing that's left? And so again, as our insurance person was alluding to, again, they buildings to be built to code down there, and the codes have gotten tougher, stronger and stronger in terms of being able to withstand Category 5 hurricanes. So the newer facilities, newer buildings are built with newer technology, newer building construction, straps, reinforced walls, and they can withstand a Category 4. This is a Category 4 hurricane when it made landfall, and you can see that high-rise building, pretty much intact in terms of outside, blown out windows and, the exterior fasciing. But it's easier to fix this than it is to completely rebuild a building. So again, that's something that that you see here. But for folks that had their houses built in the 30s, 40s, 50s, whatever, different codes at that time, so they were built to different specs, and so there's more damage with that. So one of the things any questions on hurricanes real quick, or we can maybe wait to the end?
What about Katrina?
Katrina, so Katrina happened in 2005 again, so that was a big issue down in the south. Really not so much impacts here, but what happens is, that was the case where if the flood walls didn't fail in New Orleans, the levees, then there wouldn't have been the flooding in New Orleans, but the levees failed. But the Corps of Engineers rebuilt things, and another hurricane came in, I can't remember the name, and the levees held. So the Corps of Engineers, built it to a certain specific specification, and they were able to, withstand the water. Now, I do have a section on winter weather. I don't know if I can wait to the end, or if you want to do the questions now, it's up to you. Yes, sir.
Yeah, when you state the speed of the wind in a particular hurricane, is that a pulsing type mode, or does it blow at 150 without
Yeah, so that's a good question. So in the eye wall, it's consecutive. So at Fort Myers Beach, there was 4 to 5 hours of 110 to 120 mile per hour winds.
Wow.
Yeah, so that's why a lot of devastation down there. Yes, sir.
Your diagram shows of the hurricane, of the eye wall, the air rising. How does it come in underneath?
Underneath. So what happens is,
How does the air come in to feed that upflow?
yeah, so it's a counter. So essentially, in the middle, it's a warm core system. So that means it's warm in the middle, and it rotates counterclockwise. So what happens is, I always kind of equated to a figure skater, right? So the air comes in, it comes up, and then it turns. It's kind of like a figure skater, kind of as they bring their arms in, they keep, they increase their angular momentum, and they spin faster and faster. So that's one way how it is, but really it's all the inflow from the warm waters, it's the counterclockwise rotation, it's the light winds a lot, and it's all kind of acting all interchangeably to produce that hurricane.
Okay, I think we can move forward, Fred.
Okay, so I will say, I was going to start this off, but I'm really impressed with the number of people that are wearing shorts today, because it's in the 50s outside. There's a lot of people wearing shorts. I'd be wearing shorts if I wasn't working today, but that's really good. So hold on to that gas.
Next time you come back, you can wear shorts.
I can wear shorts. That's great. So one of the things that we kind of, we get asked a lot of is our winter outlook. And so this is a chart. So you may have heard that we've had La Niñas for the last 2 winters. We're going to have a La Niña for a 3rd winter. It's going to kind of weaken as we get to like February, March. And what we call that is a triple dip. So when I hear the word triple dip, I think taking my ice cream cone, turning it upside down, putting it in chocolate, putting it in sprinkles, putting it in something else, then putting it in my mouth. Well, triple dip in the climatologist world or oceanographers is 3 consecutive years of a event, La Nina or El Nino. So here it lists all the double dip La Ninas, and the bottom 2 are the cases with the triple dip. And so again, we're gonna have a triple dip La Nina. And so what I did was I put arrows by all the previous years when we had the double dips. And you can see that the right column is the snowfall total for Pittsburgh. So keep in mind, Pittsburgh snowfall total is right around like 42 inches of snow. And you can see numbers that span from 60 inches, 30 inches, 37, 56, 40, 40. So again, we're plus or minus easily 5 or 10 inches on average during these La Ninas. So that's kind of how we use past weather to help predict future weather, what's going to happen this winter. So this is something that, this is what some other folks are forecasting. They put their winter outlook out. And so unseasonably cold and snowy says 1. The other one says cold and snowy across much of the United States. So when you see that, you're like, oh my goodness, I better, get my snowplow ready to go, service. Better get shovels, better get salt. But historically speaking, La Nina winters in Western PA, most of the time, produce upwards at worst case 15, 20 inches above average snowfall, at worst case. But most of the time they're within 10 inches of 40 inches, between 30 and 50 inches. This is the what the National Weather Service has right now. Our official winter outlook comes out later this month. So again, we are pretty much using a textbook La Nina pattern. So cold in the northern plains, warm from California to Florida and the Carolinas, and then a wet signal over the Great Lakes, and then dry conditions across the south. So this is similar to what we had last year. If you go back last year, we were right around average for snowfall. We were just a little bit above average for precipitation. And so that's something kind of we're watching for. But really what happens is it takes like one storm. So if you remember last year, In March, we had like 9 inches on a Saturday. And I was working that day. I was leaving work at 6 in the morning, and we were working overnight, the overnight shift, and this band set up to produce all this snow. And I'm leaving work, and I'm like, oh shoot, it's gonna be a fun ride home. It was like the worst day to drive home was Saturday morning. And so I'm driving on 376. This is like right around 6 in the morning. And one lane's clear, one lane's snow covered. And there's a car on my tail and like flashing lights and honking the horn. I'm like, where do you have to go at 6 in the morning when there's 9 inches of snow on the ground? But, the patient person that I am, I just kind of I finally got the, place where they could kind of pass me, and off they went. But that was the worst storm of the year last winter, was 9 inches. And again, typically we get, get inch here, inch there, it rains, it smelts, and typically snow doesn't last that long. Again, February 2015 was the second coldest month on record for Pittsburgh. That was a mean temperature, somewhere right around like 18.5 degrees. That was really cool. That's when school buses had to close because the diesel fuel gelled over and they couldn't get the buses to start. And it made me dislike winter even more than I already do. But because I grew up here in 93, 94, shoveling 2 feet of snow, and that was not fun. But it doesn't pale in comparison to January 77. When the mean temperature for the month was 10 degrees. You could literally walk across the Ohio River at the point to Three River Stadium. It was I think Three Rivers was there then, or just about. And the mean temperature was 10 degrees for the month. So that means your low was 0, your high was 20 for pretty much for 30 days. And that is the benchmark month in terms of cold for this region.
Now, Fred, what caused that? Was it just a, quote, weather event? Or?
Yeah, it's largely a pattern probably becoming locked in with cold air, very similar to what we saw. And so in February 2015, I haven't gone back and checked this out, but February 2015, the polar vortex term came around, right? And, we kept getting reinforcing shots of cold air from the Arctic. And that kind of led to that month. So probably a very similar situation happened in January 77, but nowhere near to the level 15 that we saw in 77. Now, one of the things I will tell, I don't know that I had it on here, but so we have all these technologies that we use things, and sometimes, you can look at woolly worms. I've seen ones with the black at the beginning and the end and brown in the middle. That usually means a near normal winter. If it's all black, look out. Also, you can kind of use some other folklore, right? So are the corn stalks, are they thicker than normal? That's a sign it could be a harsh winter. Are spider webs bigger than normal? This is all like folklore that people have kind of used over the years. I don't know about corn, and I don't know about spider webs, but the woolly worm I've been seeing shows it's gonna be a near normal winter. So take it for what it's worth, and but that's what we use. And so that's the winter forecast from NOAA. Just to give you an idea. So again, we're from the National Weather Service. We're part of the National Oceanic and Atmospheric Administration, which is part of the Department of Commerce. That's kind of where we fall. And we're one of 92 sites across the country that launch weather balloons twice a day. And we are one of 122 offices across the United States and its territories, Puerto Rico, Guam, Samoa, U.S. Virgin Islands. So, with that, I will take any questions that you all may have. Yes, sir.
I've got a question. Up at our house, I've got a few thermometers, and normally the temperature is, and we live in Ben Avon Heights, is 3 to 5 degrees cooler in our community than what the local radio and television stations are telling us. Now, we have good tree cover, but why would there be that disparity?
So if you're up higher,
We're at 1,200 feet.
okay, so our office, right on the Ohio River, you're around 900 feet. The airport's around like 12 to 1,400. And so there's situations where, you're up higher and maybe you're in a valley, and that maybe leads to it. So a good example is where I live. I live kind of like, well, up on a hill, so to speak. But then down the hill, it gets really cold really quick at night because all the cold air drains that lower elevation on top of that hill. And so those are situations. And here it's very hard to get, we're not the plains where it's flat and you get uniform temperatures. It's amazing. Just watch your car thermometer as you drive through on a clear night, on a clear day, when there's a strong inversion. You could be 25 here along the river, where it's cold and it radiated and the temperature's allowed to fall before the inversion set in. And up on the hill in Moon, you could be 32, 36. In our higher elevations in our mountains where we have like 4,000 foot peaks, we've seen 30 to 40 degree temperature differences between the mountaintop and the lower valley adjacent to it which is about a 1,500 feet elevation difference because of that inversion that sets up. And that's more pronounced in the spring and fall than it is in the summer and the winter.
Now, are these temperature gauges that are official gauges, are they in bright sun or shade or?
Well, it depends. I'm not really sure. So I know where our gauges are. They're at the airports, and they're sited, in the open field, so many feet up. Like our wind sensors are 20 feet up. Our temperature sensors are about 6 feet high. They're in the shade. So we all have proper sighting mechanisms for this. What people use on apps on phones and television, I'm not sure. But there are specifications when you have a weather station how you should sight it properly.
Okay.
Good question.
Question. The hurricanes are classified 1 through 5. When did they start giving them numbers?
Well, that Safford-Simpson scale's been around since the 50s, is when they started classifying those. What they used to do is we'd have unnamed storms back in the 1800s. We would never assign so initially we assigned a name to them, and then we assigned a category when they did the research. And the Safford-Simpson scale is mostly using satellite techniques initially to develop an intensity rating. The naming convention was used just to identify it when we had satellite pictures twice a day or once a day back in the 30s and 40s. Before technology.
The hurricane that hit Galveston, Texas in 1900, and
Yeah.
the one in 1935 at Key West. Okay, they would be classified as category 5s? Because of
Probably, yeah, but look at the devastation and stuff, they can go back and reclassify them, yeah. I'm not sure what they were reclassified as.
You being a professional, what's your take on the Farmer's Almanac when they always tell you about the weather?
Yeah, I mean, I'm not sure, I mean, they don't release, so we verify all of our forecasts. I don't think the Farmer's Almanac verifies their forecast, but I will say if it's cold and snowy, that helps, that helps things out in terms of sales. I'm a big fan of warm and dry winters, but I'm yet to have one of those. I need an El Nino year for that to happen, and we haven't had an El Nino year for a while, so, yes, sir.
Yeah, so the way I'm interpreting what you're saying is that your station is primarily data gathering for local weather, and you probably can forecast maybe 24 hours. Where do they do the great big models?
Yeah, so we issue a 7-day forecast every day at our office. Again, the main focus is the first 24 hours. The main models are produced in Washington, D.C. We disseminate those free of charge to everybody, and then public vendors can people can take those and turn around and sell them to TV stations, whatever. We are a big data collection platform. We are the observation network. We are the satellite network. We are the radar network. But our mission statement is the protection of life and property. So we want to issue warnings before storms hit. Not all the time, because we're not perfect, but most of the time, issue the watch a couple days in advance for a winter storm, a couple hours for a severe thunderstorm, tornado, and then issue the warning a day in advance for a winter storm, and minutes for a tornado and a severe thunderstorm warning. That's our main mission. Yes?
Just curiosity, when they show all the temperatures around the city and their territory, it always seems like it's 5 or 8 degrees warmer up around Beaver Falls, up in that area. Not real far north, but right north.
Yeah,
and I just wonder if it's something wrong with their thermometer.
Well, not every time you go north or south does it get colder or warmer, but if it's routinely, it could be a function of the site of a site, it could be a lower elevation along a river, which could lead to warmer weather. I will say that the city is warmer than out here in Moon. I always call Moon Mount Moon because it seems like the weather gets pretty interesting when we come to Moon every day. I don't live in Moon, but they seem to be a gathering site or a location for snow bands in the wintertime to come through and hit. Or where I live, 15 miles away, where I'm out of the snow bands. So with the northwest wind. So I always will tell people, if you get a big heavy snow band come through, find out what that wind direction was, because that wind direction is 320 or 310. When the forecast calls for snow showers and that wind is at 320 or 310 degrees, you could get accumulating snow. So I chose to live outside the snow bands. People in our Buffalo office choose to live in the snow bands. Different strokes, different folks.
I have 2 questions, please. Would you address, I was listening to a conversation and 2 people talking the other day, that they indicated that the earthquake that happened in Japan shifted our axis and changed the axis of the world, and that would affect weather. I don't know if that's true or not, but do you study that, and can you add any comments to it?
Yeah, I haven't heard that. The USGS handles all the earthquakes, United States Geological Survey, and changing the weather pattern from that. The only thing I will say, like, go back to the hurricanes, like if we have a typhoon, like a super typhoon, which is like a category 4 or 5 hurricane, impacting Japan, and it recurves, and it comes back across the northern Pacific, that can definitely change weather patterns for us, because those are big systems that the models have a hard time accounting for. But in terms of changing global patterns from one earthquake, I mean, I've seen volcanoes do some stuff to kind of change weather patterns temporarily, but not permanently.
Yeah, because the plates move, the tectonic plates. The second question is, I know that the sun has a flare-up of sunspots approximately every 8 years.
Yeah.
And that affects our weather. And
Yep.
I know that there was a big sun flare that just missed the Earth about, I think, 2012 or something like that. Would you comment on how that affects our weather, please?
Yes, I just gave a talk on space weather yesterday. So solar flares, coronal mass ejections, sunspots, again. So we're in an active solar cycle for the next, they'd say 10 years, maybe more towards 8, but it's when the sun has a nice organized, clean state, and then it gets to a messy state for 10 years. Then it gets back. So when it's in an active solar cycle, we see more geomagnetic storms. Well, what does that mean? It could be an impact with the communications, radio communications. It could be the northern lights as far as down as this latitude. But it takes a really strong solar storm. So again, these solar storms are rated on a scale from 1 to 5, and it usually takes a G4 to see the northern lights at our latitude, 42 degrees. It's more common at the poles. But we can see more solar storms, we can see more radio communication issues, more satellite communication issues with your TV providers. It just depends on the strength of the storm, but yes, we are in an active thing. And then the eclipse is 2 years, April 24. You drive an hour northwest to here, you can be 4 minutes and 11 seconds of totality, but it's gotta be clear outside, and it's gotta be late April, and you're downwind of the Great Lakes. So it might be a challenge. Yes, sir.
Yeah, the charts on Hurricane Ian showed buoys, temperatures from the buoys in the ocean. Can you talk about those and how they work and what their distribution is?
Yeah, so we work with the National Buoy Center, and they're part of NOAA, and we put those in strategic places where ships and ports are real popular, and also for data spacing. And essentially what they are is they're weather equipment that's on a device that floats in the ocean that's stationary, that can record temperature, wave height, humidity, wind, because it's important for us to know kind of what's going on out there. Unfortunately, the network is not as dense as observation networks are over land. So we take, they're few and far between, but when we get the data, like wave height and winds, when we have hurricanes out there, it really helps out. But we also have hurricane hunters that go out and do the surveys of the storms for us to kind of help out as well.
Are they anchored?
Yeah,
So you don't have them in the deep ocean?
no. No, the Outer Continental Shelf, I mean, no. Yes, sir.
Okay, I think we all hear about global warming, okay, and I think weather runs in cycles. All right, is there any truth to the global warming, or
I mean,
can't tell?
Yeah, I mean, the thing I'll say is, like, this is always a popular topic. I always say weather's your mood, climate's your personality. So that's a good way to kind of, do that, because no matter what I say, it may not change your view on climate. The one thing that I will speak on facts-wise is that we are seeing, historically we have the data that supports increasing rain events that are 3-inch and 2-inch an hour rain events. Last year, we had that all-time record high temperature set in Washington and Oregon at 117, 118 degrees. And when 40% of your population in Seattle does not have air conditioning, and you're at 115 degrees for 3 days, those cause issues. We had the big cold in Texas also. So we're seeing more of these wild events. I will say, looking at the 30 years, so every 10 years, we have normals for Pittsburgh, that temperature, precip, and snowfall. And the latest normals came out in 2020 showed minimal 0.5 degree temperature increase. It showed a snowfall increase across our region, and our precipitation stayed within about 1/4 of an inch. So what does that mean? Well, we are seeing about a half a day more of 90-degree days, but we are seeing warmer overnight lows, almost an increase of 4 days of overnight lows where 70 degrees or higher is the low temperature. So again, more water vapor in the air, the atmosphere doesn't cool as much in the evening, so that's what we're seeing. We're seeing warmer overnight lows, increased rain rates, because we've had more 3-inch and 2-inch an hour rain, 1 hour rain events in the last 25 years than we had in the past 120. So that's just data. But in terms of global warming and all that stuff, I mean, we're seeing, weather does go in cycles. Hopefully never go back to a cold cycle, though. Yes, sir.
Yes, I've looked at the radar, especially this summer, but in the past, it seems like the storms oftentimes come to the Ohio line and then disappear, or alternatively, they'll break up and go north and south of Pittsburgh, with more in the South Hills than to the north. Is that just a...
No, we hear that a lot. I mean, it's crazy because like we give talks across, we cover 35 counties over 3 states, and we hear that a lot. Like all the storms always go to my north and south, and I've never met one person who says I always get directly hit by the storms all the time. So I'm waiting for that person. I've been in the agency 24 years. At some point, I'll meet that person. But you are right. As storms reach the Ohio River, they have increased topography, increased hills, which really affects low-level circulation, which in turn helps, weaken the storm, so you see that. And to your point about the South Hills being hit more, we do see more tornadoes in the South Hills that we documented. I mean, there's not many tornadoes in the North Hills of Pittsburgh. There's not many out in this section either. They're focused in the city and then the southeast. That's where our flash flood events happen. Again, population and just urbanization. It seems to be more prevalent there than it is in the North Hills because of there's still some open land, but we just don't have a lot of issues in the North Hills and the West Hills. It's mostly city of Pittsburgh and points south and east. But yeah, in terms of storms breaking up, I think it's mostly because of the terrain that happens. I like to say I would take credit for that, but I don't. Yes, sir.
Do you ever offer tours of your facility out there in Moon?
During COVID, we halted it. It's really kind of a case-by-case basis. It really depends on our COVID community level, what it is. We keep them small though, like usually less than 10 people. We don't want to bring 40 kids into our building when we're in COVID high. So like when COVID high happens, we did not do tours. You can go on YouTube and we have a virtual tour posted inside. 30 years ago, 25 years ago, it was a cool place to visit. A lot of computers and everything. Now everyone's got computers. So it's really not really as eye-grabbing, not as much eye candy. I think the big thing is for people to see the weather balloon. I think that, we do those twice a day. That's something that we always, keep them outside. They see the weather balloon, how the data is, and that seems to be the highlight of our tours versus like a Weather Service 101. But you can go online and see a tour of our office inside. Yeah.
I was going to ask, when you put the weather balloon up, where does it go? How high does it go? And do you freeze them or not?
Yeah, so it goes 20 miles, about 100,000 feet. It takes about an hour and a half. We use about 1,200 grams of hydrogen. We used to use helium, but helium was very expensive. So now we get almost 2.5 times as launches for half the price. And we launch hydrogen balloons next to an elementary school. So we had the fire department come out and make sure everything's grounded. And they go about 20 miles. They get as big as a small house. They burst. They take temperature, dew point, wind, pressure, and then we used to recycle them, but now we have new devices that are very inexpensive. They're a lot more efficient, and so now we don't. When they land, they land. So when we track it, but once it goes up and it decreases pressure, but once it starts increasing pressure, the GPS turns off, so we have no idea where it lands. Typically, most of our balloons land in central Pennsylvania, Maryland, or New Jersey. It just depends how far up they can go with how strong the winds are to carry them that far east, but most land in central Pennsylvania. I've had a balloon launch that landed at the Moon Golf Course from Moon, so no wind in the sky that day. Landed right in Moon Township.
How big is the balloon?
The balloon initially, or when it's fully
Inflated.
Oh, fully inflated. I think it's 6 feet high by about 4 feet in diameter, 3 feet in diameter, and then it expands. It expands probably I would say it probably gets about as big as this room when it's all done. Yes, sir.
You mentioned there were 90-some stations throughout the country. How many are in Pennsylvania?
Just us. Us?
One?
Yeah, Pittsburgh. Yep, we're the only one that does them. Pittsburgh, Buffalo, Cincinnati are the nearest ones in Detroit.
If a young person wants to get involved in meteorology or your kind of job, where would he go to school for this?
Well, I would tell him to go to Penn State, but that's just me because I went there. I saw one guy wearing a Penn State shirt here. No, but there's lots of options now. So, Cal U, which is now Penn West, California, I think is what it's called. They have a meteorology program, Ohio University, Ohio State, Penn State. And we have people in our office from SUNY Albany, and I'm just trying to go through the list where we have Wisconsin, Georgia. So we have different schools across the country, they can get involved with. It's they got like math and science. There's a lot of math and science the first 2 years. Pretty much your first 2 years are on track with an engineer. And then you get into more math, sadly. And then when you come out, I use about 4 classes for my undergrad for my job. So I got into all this math and science. Now all I just do is talk to people. So it's crazy how your times, your path of life changes as you get older.
Fred, we've got a microclimate here in southwestern PA. When you put the fertilizer down or whatever in the spring, you look at the map on the back of the bag, and our climate is similar to what you'd see in Cincinnati. I don't know if you've ever noticed that, but is that because of the, obviously, airflow or mountains around?
Yeah, it'd be southwest winds. I would say Cincinnati gets a lot less snow than we do. I think Cincinnati averages 20 inches of snow a year, but in terms of the springtime, it can be a function of the southwest winds bring up to Interstate 70, and you definitely hit a wall as you go north to the Great Lakes where those cold lakes really stop. The air from penetrating. I remember, during the Hempfield tornado back in March of 2011, that it was 72 degrees in Morgantown. It was 36 degrees in Erie.
Yeah.
Strong differential temperature.
Now, the rivers in southwestern PA, could they have an impact on our microclimate also?
Lower elevations. I remember, if you remember back in, was it 1990? 1992, it snowed on Halloween. I forget the year it was. I was trick-or-treating in the snow, but if you lived down here in Swickley, you had no snow. It was an elevation-dependent snow. They help with temperatures like that in the transition seasons, but overall, they don't really have much impact in terms of our weather. The River Valley fog, you'll see that a lot, but in terms of directing systems, we've had tornadoes that go across rivers. I did a survey last year up in Elk County and Jefferson County. We had the tornado just hug the river. It just hugged the river, mostly on the Elk County side, but they have some impacts with that. But overall weather patterns, they do not.
Okay, thank you.
Yeah. Yes, sir.
What I found when I used to work in Pittsburgh, heavy snow. I lived up on Moon. As long as I could get down the hill, I'd get along on 65, and it'd be nothing but slush.
Yeah.
Because of the
Lower elevation,
the river.
warmer temperature, closer, and the water keeps the river temperature keeps it warmer. Yep. Always good questions in this group.
You're not going to ask a question from 1901, are you?
Hang on a minute. Hey, I want to ask you, do you remember the thing that came through Biloxi, Mississippi? That storm that came through there?
I do not. I know our Mobile office last year had 7 hurricanes go in their region. So was it last year or was it a long time ago?
Oh, it was a good year. I don't know. I'll give it 5 or 10 years back.
Oh, Camille. Okay.
Biloxi, Mississippi.
Yeah, that was
I
a bad
got
one.
involved in that. And the other one I was involved in is in Homestead, Florida.
That's Andrew or Wilma?
So I flew down there to Biloxi, Mississippi. They asked for help, see? And all this government reserve, they say, that's going to go in there. I've never seen one damn one there. And they hired me to, they asked me to come down. It was all volunteer work, and I was framing in roofs for the houses, we'd tear off the trash and fix the roofs. We fixed, personally, 5 of them that I worked on. All the volunteers that came down there was from all different kind of churches. And they did give me a room to stay in. It was free, right on the beach. I had to go up to the 3rd floor because the first 2 floors were all flooded out.
Oh, jeez.
But the help they say that the government's going to give you doesn't happen. Then I heard a speech that our illustrious president said to Florida people that they're going to stop all of this because they're going to have everybody using electric instead of that fossil fuel. Or unless this president's going to put a stop to all this.
Yeah, it's, one of the things I'll say is that,
What do you guys do to listen to him?
we always walk, that's a political tightrope, that we just try to keep ourselves out of that. One of the things I was going to mention is, I'll come back to me. See, I'm getting older. I'm not in this group yet, but you know, I'm just my mind. I had someone else going to tell you, and then
We're looking for new members.
yeah, I know. I got to. It'll come back to me. Yes, sir.
Just a quick question. I see that map up there, and my eyes aren't real good anymore. The nice green over there covering us for seasonal participation.
Yeah.
What does that mean? Does that mean we're going
Above average precipitation. Yeah.
and the kind of the temperature thing, which is kind of a fleshy color there?
Yeah.
That's also below average?
That's slightly above average. The tendency is to be slightly above average.
Below average.
Above. So above average temperatures and above average precipitation hopefully means rain. Hopefully.
Okay, Fred?
Okay, when you were talking about the weather balloons and sending an instrument package of some sort, how big is that instrument package? Because it just falls somewhere, and if your car happens to be parked in the wrong spot, and something comes flying out of the sky, you know, is it going to take your rear window out, or is it so small that it bounces off, or?
I should show up an image.
Send the bill to the,
Yeah. One thing I forgot to mention is, so when we fill this balloon up, again, 1,200 grams of hydrogen, we have our instrument's about this big. It's definitely smaller than a shoebox. It's very light, lead about 2 pounds. And we have a parachute in between there, so when it does fall, the parachute opens up and slows the terminal velocity of it coming down to the ground. And most of them just get stuck in trees, because the trees are the first thing they hit, and they get stuck up there. But yeah, that's a good question. That's, I forgot to mention the parachute. That's a safety thing. And, yes, sir. The back.
Do you retrieve those things? Is there a GPS on those things that you have to retrieve them?
Not anymore, no, we don't go out and retrieve them. We used to get about 10% back, but now they're so small and they're efficient that it's just not worth it for us. So they're biodegradable material now.
throw away economy.
Yeah, they've really changed. They've gotten a lot smaller with time. When I first got in, we were soaking a dry cell battery in water for 5 minutes. Then we were plugging in wires. Now I just put it on this device, it powers up, calibrates, off it goes. So it's, it's amazing how things have changed over 24 years.
Okay, any other questions for Fred? There we go.
Yes, Bill.
We have 2 radar systems, yours and the one at the airport. Do you in any way assist one another, or is there data that can be used by one another?
So when you say the one at the airport, you mean Pittsburgh International?
Oh, yeah, the airport.
So our radar, there's not a radar, the radar at Pittsburgh International, if there is one, I'm not aware of one, it maybe just monitors the air traffic. The airport does, the FAA does own a radar in South Central Beaver County, it's called a terminal Doppler. We do use that, and that actually has really good resolution for us to see storms in northern Washington, Columbiana, Hancock, parts of Allegheny County, or storms when go over top Moon. So what happens is when storms go over top Moon, our radar is a cone, right, or a circle, and it's got this called cone of silence, because the antenna doesn't go straight up. It stops like 21 degrees or something, and then. So when storms go over top Moon, we can't see anything. So we use the terminal Doppler at Pittsburgh, South Central Beaver County, to use that. And that's why radars are not put downtown. So when I came here from New York City, even though I'm from here originally, I used to work at our New York City office, our radar was out in eastern Long Island, so we can see the 5 boroughs of the city, versus putting it right downtown Manhattan, or Queens, or wherever. But yeah, that's good. But so we do use it, yes. When we launch weather balloons, we contact the air traffic control tower, let them know weather balloon's going up, so when pilots know to look for them, but they're aware of that. Yes, sir.
Yes, sir, I have a question. Hurricane Harvey that came in over Houston, and it just sat there and just dumped tons of water on the place. What caused the thing to stall like that?
Yeah, so really it's going to an environment with really little wind. And the hurricanes by themselves don't really move that fast, usually less than 10 miles an hour. And this thing made landfall, and it made landfall, I forget what month it was, but there's not a lot of wind in Texas in the summertime. And so the problem with Harvey is that we were forecasting 40 inches of rain. And when you hear 40 inches of rain, okay, that's probably about, 3.5 feet. That's like this much water. Okay. Well, the problem is you magnify that over an entire county, that caused catastrophic effects. So like Florida, right? So Florida, we were forecasting 25 to 30 inches of rain. And you saw Interstate 75 was shut down south of Sarasota because of all the rivers were in major flood in Florida. Because again, it's hard to visualize. It's easy to visualize 25 inches of snow, because you can put your hand out 25 inches, but rain and the scope of how big of an area it encompasses is hard for people to realize the impacts that come with it.
Such low elevation in Florida.
Yeah, and a low water table too. Yeah, even though it's got sandy soil, it was too much for the system. Yes, gentleman in the back.
Yeah, question. You watch the news, they say the American model and the European model. What's the difference?
Well, it's just the math equations and the physics go into it. I'll be honest with you, the way we do our forecasting now is more statistical. So we take all these models, American, European, and we have, I think we have like 46 of them that we use, and we run statistics on them, and we get rid of the lowest 10%, get rid of the highest 10%, do a 7-day bias correction, and then find out which is the cluster the best fit, and that's kind of how we do our forecast, and it does really well. When the forecast and the models are very consistent, it does very well. But when we have dramatic changes, then that's where we have to kind of add value to it. But now it's more statistics than anything in how we do our forecasting. That's like analytics of sports now is becoming a big thing. Statistics is big for us. Okay, there's an 80% chance of seeing 36 degrees this weekend. That gives us high confidence we're going to see 36 degrees Fahrenheit. So it's a different spin on things to relate forecast confidence in our forecast.
Any other questions for Fred? Great presentation.
Yeah, thank you guys.
Learned a
Appreciate
lot.
you guys having me. Thank you, sir.
Look forward to having you back again. Okay, that's it, guys. See you next week.